Hello and welcome back for 22.1 Solving Equations by Taking Square Roots. Before we go into this lesson on how to solve by taking square roots, we're actually going to review how we simplify radicals, or square roots, if you will. So I put a list here in the PowerPoint of all your perfect squares. Go ahead and jot those down somewhere in your packet to keep them as a reference. I'll be using them throughout the slides, but just it's nice to kind of keep that in your notes for the test. As a quick reference. So the way we're going to simplify is we're actually going to factor 48 as a factor of two numbers. But we're going to pull from these factors here because as you can see, all of these numbers here, you can actually square root. Okay? So I don't know which one's going to work, so I'm going to divide 48 divided by 1, 48 divided by 4, 48 divided by 9, 48 divided by 16, and 48 divided by maybe 25 and see if that works. I'm not going to go all the way because as you can see, I want this number to be a little bit smaller. And what we're going to do is pause right here, go ahead and divide each one out and see which ones give you a whole number and the highest whole number you can find. So 48 divided by 1 be 48, so that doesn't really give me anything. 48 divided by 4, as I can see off, would be 12, so this might be a winner. 48 divided by 9, on the other hand, would get me a decimal, so I'm probably not going to use this one. 48 divided by 16, though, gets me a 3. And 48 divided by 25, yet another decimal, so no, I'm not going to use that one. So out of these two, it looks like 16 is the bigger number, so I'm going to try 16 and 3. And as from my list, I can see that square root of 16 is 4. Square root of 3, if you do square root 3, it's a long decimal. In fact, I'm only going to write this down once. The reason why we leave it in a radical, as you can see in my answer box, is because not a lot of students want to write down this every time they get a perfect, or not a non-perfect, I should say, because this does not look perfect at all, right? No one wants to write that many decimals down. So the next thing we're going to do is you'll see that we're multiplying these two together. So I'm going to go ahead and multiply 7 times 28 first. And figure out what that would be. So pause, figure out what 7 times 28 is right now. And you'll see that's about 196. And as I'm looking at my perfect squares, I'm going to look for 196 before I start factoring. And I find, ooh, it's right there. The square root of 196 is actually 14. Yay! So that one we really didn't have to factor too much. On this next one, for 75, I'm going to go ahead and find my two factors. Again, I'm going to just list out some factors here. 75 divided by 1, divided by 4, divided by 9, 16. Hey, maybe 25 would work. So go ahead and pause right here and try and figure out which one of these would work. And if you unpause, we would have found that that would have been 25 and 3. And the square root of 25, as you can see here, is 5. We're at 3. Cool. All right. And 6 times 24, I'm going to go ahead and multiply 6 times 24. Again, off screen, or pause right here and figure out what 6 times 24 is. You would find that's 144. As I'm looking at my list, I'm going to see, can I square root 144? Yes, I can. I can square root 144 to be 12. Cool. Let's continue on. So square root of 98. So again, I'm going to go ahead and figure out what of my factors. 98 divided by 1, 4, 9. I'm going to just keep going down the list. You can try 25. I don't know how much luck you'll have there, but try it out. 36, and then 98 divided by 49. So try those out. Pause. Tell me which one worked out for you. But 98, I believe, our factors would be 49 and 2. Since 98 divided by 49 is 2. I can square root 49. And I'll leave rad 2 in a radical, or in a square root, however you want to say it. So that one's done. Let's go on to number 8. That would be 5 times 45. So take some time, pause right here, figure out what that would be. And unpause, that would be 225, which I'm looking at my perfect square roots. And I know you kind of can't see it, but the square root of 225 would be 15. So I can write that as a 15. Awesome. Let's continue on with number 9. Again, listing out your square roots. So again, I'll do 108 divided by 4, 108 divided by 9, 108 divided by 16, 108 divided by 36. Now, notice how I skipped 1 because, you know, it's not going to change much. I skipped 25 also because it doesn't end in a 5, so it's probably going to get me a decimal. 108 divided by 49, and just pause right here, see which one will work out. Okay. And should have found that to be 3, so that would have been 36 and 3, that would be 6 and rad 3. I'm going to go ahead and multiply these two together. 5 times 20, which would be 100. And if I look down my list, ooh, yay! Square root of 100 is actually 10. Cool. Let's continue on to dividing radicals. Okay, so as I can see here, I have a numerator and denominator. I can go ahead and square root both numerator and denominator. And I see they're both perfect squares. Why not? Let's try it out. So that would be 4 and 3. Now the reason I split that off is because I noticed that these two appeared here. So I thought, hey, why not, right? They square root. It's just easier this way. As I'm noticing here, 96 and 6 are not at all in the perfect square root column. So I'm going to go ahead and put them under one big radical and see if I divide 96 divided by 6. Go ahead, pause, figure out what that would be. What would that be? Ooh, 16. And is there a 16 on the list? There is. So that would be 4. So just one strategy I used here, I square rooted both numerator and denominator because they were perfect squares. And I can square root perfect squares. Here, because they were not perfect squares, I kind of decided to divide first and see if I got a perfect square, which I did. So I was, that kind of worked out. Let's try the next one. Ooh, 25 and 49. Let's see if we can find that on the list. There's that and that. So I could square root 25 and I could square root 49 and I could get 5 over 7. Well, that worked out. As I'm noticing here, 75. Do you see it on the list? Oh, man. 3? No. Well, let's see about dividing them out. So take some time, pause, work it out. What'd you get? Square root of 25. Ooh, square root of 25. I know that squares it. We can get a square root. Cool. Square root of 25 would be 5. Yay. All right, moving right on down. We'll get this one. Hey, that's a perfect square. It's right there. And that's a perfect square. That's right there. Let's try this out. So that would be square root of 1, square root of 25, which would be 1 over 5. Yay. Now I'm looking at 42 and 7. Not perfect squares. So let's go ahead and divide it out. Take some time, work it out. 42 divided by 7. And I get the square root of 6. Now I notice that this is not a perfect square, but I know I can't really break it down. In fact, if I tried, those would be the only factors I could think, and none of them are perfect squares. So I'm going to kind of just leave it as the square root of 6. All right, moving right along. Oh, perfect square. Perfect square. You're like, where? See, here and here. So that would be the square root of 64, square root of 36, 8 over 6. And we could reduce it to be 4, whoop, sorry about that, 4 over 3. But hey, at least you know we're almost done with the getting square rooted, you know, having all that practice done. Oh, 27, oh, not a perfect square. 3, ah, not a perfect square. So let's go ahead and divide 27 divided by 3. And that would be, ooh, 9, which is a perfect square, which would be about 3. Awesome. On the next video that we're going to be doing, we are going to be applying all this awesome knowledge that we just went over with square roots on our next lesson, which will begin with solving each equation using square roots with number 1 here. All right, see you on the next video.